Hello everyone. In this lecture, let us have a look at edge detection. As we are going to be performing this operation live, please make sure you have either a camera, which is either default that is inbuilt, or an external one. So now, let us go ahead and see how to create the code for edge detection. So in any operation in OpenCV, our first step is to read in our library, which is CV2. Along with it, let us also read in NumPy library as NP. Our next step is to read in our camera frame. So let's create a variable called cap, and inside this let's write cv2.video capture. Now inside this I am going to be entering the value 0. This is because I am going to be using my default camera, that is the inbuilt camera present in my laptop. In case you're using an external camera, please enter the value 1 within the brackets. So now that I have read in the frame of my camera, our first step now is to create a while loop. So while, let us say 1, because I want the loop to keep running till the time I'm asking it to stop. So now creating two variables, ret, frame. What I'm going to do is I'm going to read in the image or the frames captured by my camera one by one using in the read function. So now that I have read in the images one by one, first what I have to do is display my original image. So I'm going to say cv2.imshow. Let's call this window as live feed and give the variable frame over here. Okay. Now after this, what I want to do is that I want to be able to apply my canny edge detection. So let's create a variable called img underscore edge and apply our cv2.canny function over here. So this function takes in 3 arguments. The first argument is going to be our frame or our source. The next 2 arguments is going to be the minimum and maximum aperture values. Normally, we can say aperture can be defined as an opening in a lens that's with respect to a camera where the amount of light falling through this lens is moderated. So over here, I have to give a minimum and maximum aperture value. So in total, I'm going to be giving 2 values and then I shall have a cluster of windows present. So first, let's give the value, let's say 10, 100, and let's see what our output is going to be for the aperture value 10 to 100. So using cv2.imshow, I'm going to say edge detection on live feed as the name of my window, and over here I'm going to give img edge. Using the if cv2.wait key, let's give 5 milliseconds and 0xff is equal to ord, let's say q. Then what I want to do is I want to break away from the while loop. When this happens, I have to first release my capture. After that, I have to destroy all my windows. So what we'll do is we will first run with 10 minimum and 100 maximum aperture values. Then we shall try another set of aperture values, and each of these times the window will be individual. That is, I'll have my original as well as the edge detection present for these 2 values separately. After which I'll have a total of 4 windows where one window will be my original image and the other 3 windows will have 3 different aperture value ranges. Okay, so let's run this and see our output. So As you guys can see on your screen, on the left we have the original or the live feed, and on the right we have our canny edge detection using the values 10 to 100 as our aperture. So I'm going to be showing the same output in all the images. I'm going to show 5 fingers, then 4, 3, 2, and 1. So you guys are seeing the output on your screen right now. After this, what I'm going to do is I'm going to change the aperture values from 10, 100 to 100, 200, and then let us see our output. So as you can see, I've changed the values from 10 to 100 and from 100 to 200. So let's run the code all over again and see our output now. So as you guys can see, there is a big difference between the aperture values 10 to 100 and 100 to 200. You can see that there's no background noise or background edge detection which has been present in the values 10 to 100. So now what I will do is I'm going to now be adding couple of more canny edge detection codes. That is, so let's say I'm naming this as apt 10 to 100. Similarly, I'm going to be having, let's say 100 to 200, and between these two values, that is 10, 100, 100, 200. So let's say 50 to 150. So these are the three aperture values I'm going to be having. I'm going to create the code for the same, and then let us go ahead and see how our output looks like. So as you guys can see on your screen, I have created the codes for 10 to 100, 50 to 150, and 100 to 200, and also displaying the respective outputs together. So let's first read in the camera image, then let's execute this and see our output. So as my images are too big for my screen right now, what I'll do is I'll close my original image and only display the three canny edge detection images for you guys. So on your screen, what you guys see is on the left, you have 10 to 100. On the right, you have 50 to 150. And in the center, you have 100 to 200. So I'm going to be showing you guys the same output I showed you for the two previous images, which was 10 to 100 and 100 to 200 aperture values. So I'm going to be showing you 5 fingers, then 4, 3, 2, and 1. As you guys see on your screen, there is a big difference in the edge detection for the aperture values which are present. That is, in the first image, lots of edges have been detected. In the second, the number of edges have reduced. Finally, in the center image, you can see that only the essential edges are being detected, whereas the others are not. So, why don't you guys go ahead, try out different aperture values and see the output. Thank you. See you guys in the next lecture.